Hey, what's going on, everybody? So, this is the rest of the notes for Kirchhoff's law. Um, and we left off in my last video up to a series circuit example. So we're going to go over the parallel circuit example here. This is the same example that we have from the notes. We have a 9-volt battery. We have a 1,000 ohm resistor, a 1,500 ohm resistor, and a 2,000 ohm resistor. So the first thing we really need to think about is Kirchhoff's law here, okay? And according to Kirchhoff's law, in parallel, E, aka voltage, is constant, and current, I, adds up. Okay, so the next thing we can do is we can start to add our different elements in as we go through here. So let's start off by adding the things that we know. So we know the voltage is 9 volts. We know the voltage is constant throughout, so we're going to put 9 volts at each point. We don't yet know our resistance total because we need to calculate it. We don't know our I total because we need to calculate it. We know that I is going to add up, so we don't know the I for any of these, but what we do know is we know the value of each of the 3 resistors individually. We know that resistor 1 is equal to 1,000 ohms or 1 kilo ohm. We know that resistor 2 is equal to 2,000 or 2 kilo ohms, and we know that resistor 3 is equal to, resistor 2 rather, is 1,500 or 1.5, sorry. And we know that resistor 3 is equal to 2,000 ohms or 2 kilo ohms. Okay, so that is like the beginning of this process that we can start with. So first of all, we need to then go back and we need to say, okay, let's take a look at how we're going to go through this process of solving for a total resistance. So again, in parallel is 1 over resistance total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So we're going to say 1 over 1,000 plus 1 over 1,500 plus 1 over 2,000. All right, so I'm just going to jot that into my calculator here. All right, so that gives me this decimal point. Don't forget to hit the x to the -1 button. And that gives us our total resistance here, which is 461.5. 461.5 ohms. Again, round to the nearest tenth. After you convert to your metric prefix, no need for a metric prefix, so just round to your nearest tenth. So now we can use Ohm's law. And again, Ohm's law, before I do Ohm's law, I always jot down the circle. E over I times R. So I'm trying to solve for I, so I'm going to cover up I. I total is equal to E, which in this case is 9, divided by R, which in this case is 461.5. So when I take 9 divided by 461.5, I come up with 0.0195 or 19.5 milliamps. Now, up here, I'm going to jot down both because 0.0195 is the value that I'm going to use for my calculations. That kind of looks like a 1, so maybe I won't do that. Or I can say 19.5 milliamps. I'm like running out of space, right? So again here, current is going to add up. So what we know based upon Kirchhoff's law is that I1 plus I2 plus I3 are all going to equal our I total. So this plus this plus this is going to equal 19.5. Now, this problem will come out exactly correct. Some problems that you have, the rounding is going to throw off your numbers by a few tenths. That's okay. As long as you can make like a strong correlation between like the addition and what you have, then most likely your answer is correct. You also, of course, need to work on setting up your resistances and metric prefixes and making sure that they're right. So when we go through to calculate, again, I, it's simply voltage times resistance. Or I'm sorry, voltage divided by resistance, pardon. So when we come through here, we're going to say 9 divided by 1,000, right? We got to use our base number here. So that's equal to 0.009 or 9 milliamps. The second one here is 9 divided by 1,500, which is equal to 0.006 or 6 milliamps. And then lastly, 9 divided by 2,000 is equal to 4.5 milliamps. So 4.5 plus 6 is 10.5. 10.5 plus 9 is 19.5, which is exactly what we calculated before. And I just want to kind of point out, remember, electrons are always going to take the path of least resistance. And also remember, the current is a measurement of how many electrons are going past the point at any given second. So our lowest resistor, which is resistor 1 and 1,000 kiloohms, right? That's the path of least resistance. That has the most amount of electrons flowing through every second at 9 milliamps. Resistor 2, which is the middle child here at 1.5 kiloohms, ranges at 6 milliamps, while the highest resistor, 2 kiloohms, has the lowest currents. Because again, resistance is indirectly proportional to current. Inversely proportional to current. So the higher the resistance, the lower the current is going to be. All right. So that's a quick 7-minute lesson on how to do Kirchhoff's law in parallel.